One, start.
Hello, hello guys. So I am Rahul Shet, and these are my team: Naman Kabadi, Prajul Gaonkar, and Dhanush Naik. And we are presenting our project called "Impact of Music on Human Health Using Brain Signals." Next. So these are the contents, and our problem statement states that development of machine learning models to analyze impact of music on human health. And this model will explore the influence of three distinct musical genres on brain activities. Further, our understanding of music influence and well-beings. Next. So introduction. So music plays very important role in our daily life. So like we can see that it is a profound ability to influence emotions and cognitive states. So in response, our projects like proposes are very novel approach leveraging on EEG data. So by using EEG device, we collect the EEG data from the using brain signals, and they are alpha, beta, gamma, theta, and delta. So in our work, what we do is we just collect the data, brain signals using EEG device, and based on three different music music genres like pop, classical, and instrumental. Next. So these are our objectives. Our objective is to analyze the impact of music on human health using brain signals and compare the finding of graph using graph through graphical representations. So we also uh, explore the influence of three distinct genres, which are pop, Indian classic, Western, and classic musics. So we have used three different musics. Like for Indian classic, we have used an Alebela song. For pop, we have using uh, Hollywood song, and for instrumental, we have using Beethoven music. So our objective is to develop a machine learning model to analyze the impact of music on human health using these brain signals.
And then we come to literature survey, where the first paper tells us about the in-depth examination of the research landscape surrounding the recognition and analyzation of musics based on the emotion and the EEG signals, where they find what are the methodologies and the challenges encountered when music emotions recognition based on EEG data. Then we go to the second paper, where they are doing the same thing but using a different algorithm called as Ganger causality or a transfer analysis, where neural dynamics associated with emotional states. Next page. uh, then we go to the third research. This was based on the traditional folk, and this was done by the Chinese authors, where different types of traditional music of Chinese, based on different pitches and different instruments, they tried to provide the analysis. Then on the fourth, they told us about the perspective of EEG based EFDFs, where they leverages CNN to automatically learn feature of EEG data. Then for the fifth one, they provide us the fusion of psychological inspired symbolic and acoustic features, like with different models and facets of the musical expressions. Then we go to system architecture. This is will be explained by Prajwal.
Uh, Coming to the system architecture, first we will be collecting the data set from the EEG device from the people, and we will be feature processing the data which we are collected in the form of CSV file, and we will be splitting the data to train our machine learning model, which will be using the Resonate 152 model architecture. And using that model architecture, we will be streaming the data and processing and giving a graphical representation of the data. It will be data visualization, and we will be getting the output in the form of before and after data comparison and the threshold of the board data. Next. This is the block diagram of our project. First, we will upload our EEG data files. and then we will clean the data and extract the features. Then we will train the ResNet model, and it will predict what is the impact happened after hearing the music on the person. Then we will visualize in a graphical form, and it will be considered output in a graphical form. Next. Coming to the brain mapping, we are using a Muse2 device. It is an EEG device. It is having a 4 channels, in a two in a temporal, and a two in a uh, front of our brain. As we can see in this diagram, there is AF7, AF4, and TP9 and TP7. These are the locations where the channels are placed. Next. Coming to the device, as I have already told, this device having 4 channels, two TP9, AF7, AF8, and TP10. These channels collect the data from different locations of our brain. Next. We will be collecting the different brain signals. Coming to the brain signals, there are 5 types of brain signals, namely delta, theta, alpha, beta, and gamma. These signals are differentiated based on their frequency of that data. As delta is from 0.5 hertz to 4 hertz, theta is 4 hertz to 8 hertz, alpha is 8 to 12, beta is 13 to 32 hertz, and gamma is from 32 to 100 hertz. Different brain signals have different effect on our human brain. As if the delta waves are coming more, then he is in a deep sleep mode, and if gamma is more, then he is on a highly concentration mode, and he is concentrating on some things while he is working and all. And if beta is more, his anxiety is high, and or his externally attention is high. Next.
So coming on to the implementation part, I am going to cover up that part. So first stage, we have collected data before listening to music and after listening to music, and we used to calculate the accuracy of the model that we are going to build. We have used accuracy formula, that is total data points which are provided divided by the total data points available in the data set, and we are calculating the mean absolute formula using these formulas. And coming to the EEG CSV data, it looks like the in this form, and the data, it contains various columns of the 4 channels, and each at regular timestamp would be recorded. And coming on to the results, so this is the user interface which will look like, where the user can upload the .csv file before listening to music and after listening to music. And after the processing, after clicking on upload button, it will give the results in this form, where we are doing the comparison between the different brain signals, and their frequencies would be mapped. And after a comparison, we can see that the threshold and the before and after line plot would be plotted here. And also we have calculated the overall mean differences for the various different bands available here, and which will give the overall comparative results to the of music on human health. So these are the between the beta band after listening to and before listening to the music, comparison is made here. And also we have plotted a heat map which shows the differences between before and after listening to music. So coming on to the conclusion, so we analyzed thoroughly the impact of music on human health by graphically representing and differentiating between the impacts of the music on human health between the different brain signals. And we also explored on the three types of music genres which will have a diverse impact on the human brain activity and mood swings. Also, we developed a machine learning model which will improve the accuracy, and it calculates the impact of music on human health, and gives a relationship between the human well-being and the music connections. Coming on to the future scope, it can be expanded for the wide range of other kinds of music genres and incorporating more advanced machine learning techniques to improve the accuracy of the models that we are going to predict. Additionally, we can also work on real-time EEG monitoring for the other applications like in healthcare sectors and in the music therapy aspects. And also there can be enhancement can be done for in the health industry. So that's all.
Naman, can you show
So
the
coming on to
code?
the
Just
yeah.
run the code.
So this is how it looks, our UI interface, and when we click on the go to upload page, we can upload the dataset. Before and after. Once we click on the upload button, we get the insights of the comparison between the different brain signals. So that's all. Thank you for watching.